Hello everyone, welcome to this video. Today in this lecture we'll learn about space-time complexity. You might encounter this space-time complexity every now and then in programming. It's the of algorithms and like these things. So first of all, let's learn about time complexity here. Complexity is basically the amount of time taken by an algorithm to solve a problem or to perform a particular function or a particular task by computer. So technically, if we try to define time complexity more technically, it basically quantifies the amount of time taken by an algorithm to run as a function of the length of the input. And also keep in mind that the time to run is a function of length of input and not the actual execution time of the machine on which the algorithm is running. So that's the basic, I would say, definition of time complexity. Time complexity is basically used to check the efficiency of an algorithm and its suitability for any particular problem or task. So that's is a simple and brief definition of time complexity. Now there are three basic and important cases in time complexity. There are any algorithm can be best suitable for any particular task or function. Any algorithm can be average or it can be worse. It can give you a worse time complexity. So let's discuss all these one by one. uh, First of all, we have omega notation. We use omega notation is basically a notation to use uh, the best case scenario in time complexity. What best case scenario means? It is the minimum time. Best scenario case scenario means the minimum time is taken to perform or to solve a problem, to perform its task or to solve a problem by an algorithm, right? So that is what we call the best case scenario in time complexity, and we represent that by omega notation, right? And next we have theta notation. Theta notation, this notation is used to represent the average case scenario. Like we have an algorithm which is neither good neither bad, right? It's in average. It's an average. It's giving us an average time complexity to solve a particular problem. So they use theta notation to represent the time complexity of that algorithm, right? Now next we have Bikov notation. It is one of the most used notation and representation of time complexity, right? It basically represents the worst case scenario in time complexity, in which an algorithm take maximum amount of time to solve a problem or to perform a task, right? So that's the brief definition or explanation, I would say, of time complexity. Now let's also define our space-time complexity here. Though it's not in the domain of this course, but let's just simply define space complexity as well. Complexity is basically the amount of space taken by an algorithm while solving a problem, right? It's the amount of memory used by an algorithm to solve a problem. Like while executing the program, the input values need to be stored in the memory in order to perform particular operation. So the space complexity, here's a small typo here. So the space complexity is basically the amount of memory taken by an algorithm to solve a problem. So that's the brief definition of space complexity. Now let's go to our Visual Studio and solve some of the problems and analyze the time complexity of each one. So we are here in our Visual Studio now. Without wasting any time, let's create a new file. Let's name it time complexity .java. Let's save it. Here our class has been created. Let's write the main function. Now let's solve some problem and analyze the time complexity of each one. First of all, let's say we are given a question to add just two numbers, sum two numbers. We are given the question to sum two numbers. So let's suppose we have integer a is equals to 10, integer b is equals to 15, and in the sum, which is the summation of both, which is equals to a plus b, right? And let's print out the sum. So here what we will be doing is, in the first line, if we analyze this code, in the first line we will be getting a variable, and the second line we'll be getting another variable. So the time taken by this operation would be 1 unit, and this one will also have 1 unit of time, and here time taken by this line will be adding these two, so this will take 1 unit time as well, and then assigning it to variable sum, so it will take 1 unit time here as well, and then it will print out the sum. Now here two numbers have been added, so the time complexity for each operation is 1 and here we have 2, so the total time complexity will be 4 units, right? So time complexity of this will be 4 units, and when we have a constant complexity, time complexity, at that time we use time complexity will be big O of 1. We use 1 when we have a constant time complexity. So that's the time that will be the time complexity of this simple algorithm to sum up these two numbers. So that's the time complexity of this algorithm. Now let's remove this and discuss time algorithm for any other. Let's say we have given a question to print a rectangular shape with stars, right? With stars. So to simply we can solve that problem by for int I is equals to 0, I less than let's put some number of rows and number of columns here. Int row is equals to, let's put it 5, int your column is equals to 7. Yeah, column is equals to, let's put it column is equals to 7, and let's say first our number of rows is equals to r, and I plus plus will increment after each iteration, and then let's take a nested loop which will run from j is equals to 0 to j less than number of columns, and increment each by each after each iteration. And here we will be printing a star, and after each row has been completed, we'll print out a new line. Now let's run it. Here you can see a block of star has been printed. Now let's discuss the time complexity of each one. Here in this line, if we start our analysis of time complexity from this line, here we have a number given to variable. So this will take 1 unit of time. This will take one another unit of time, and it will be constant unit of time here. Here you can see that this loop will run r times, and this loop will run r times, while this loop will run c times, right? So from this we can conclude that time complexity of this algorithm would be equal to big O of n cross c, n cross r, I'm sorry, n cross r. So this is the time complexity of this algorithm, right? Hope you'll understand it. Now let's solve one more question so that we can understand it clearly. Another question, let's say we have given a problem to print a triangle with stars, right? So how we can do it? First of all, before that, let's declare a variable n, which is equals to 5, which it is basically the number of rows and columns in our triangle, right? So it will start, our loop will start from I is equals to 0. I is equals to 0. It will run till I is less than n, and it will increment in each iteration. Then in our nested loop, our j variable will start from 0 as well, and it will run till it is less than I. It iterate till it is less than I, and it will increment itself in each iteration. Then we will print out a star here in each iteration. After each row has been completed, we will also print new line here. So now let's run this and check it if it's working. Now here you can see a triangle of stars to be printed. Now let's analyze the time complexity of this algorithm. Our time complexity would be T of n would be equal to, here you can see that we are this loop is running like this loop is iterating n time, which means it's running n time. This is also running n time because it is starting from 0 and it's going from 0 to less than I, which is equals to from 0 to n, which is also equals to n times. Now our time complexity will be big O of n times n, which is basically n squared. So that's how we can analyze and find time complexity of any algorithm. Hope you'll understand it. Today we learned about space-time complexity, and in the next lecture we'll be learning about arrays in detail. Till then, keep learning and keep improving yourself. If you find this lecture interesting and beneficial for you, please don't forget to like, share and subscribe to the channel. Thank you.